Radical Equations Lesson 1. This lesson will focus on solving equations involving square roots, determining the roots of a radical equation algebraically, and modeling and solving problems with radical equations. When solving a radical equation, we must remember to identify any restrictions on the variable and identify whether any roots are extraneous by determining whether the values satisfy the original equation. That means that we must verify our solutions. Example number 1. State the restrictions on x in 5 plus root 2x minus 1 equals 12 if the radical is a real number. Because we're dealing with a square root, that means that whatever's underneath my root sign, so in this case 2x minus 1, must be greater than or equal to 0. I now want to find values of x that satisfy this. Two different ways of doing this. The first one is that I can solve this linear inequality. To solve the linear inequality, I can add 1 to both sides, and I get 2x is greater than or equal to positive 1. Next step is to divide both sides by 2, and we get x must be greater than or equal to 1/2. The other method is by trial and error. I want to see what makes this a true inequality. So I want to substitute in values for x. So I can try something like 0. If I substitute 0 in, I end up with 2 times 0 minus 1 is greater than or equal to 0. 2 times 0 is 0, so I end up with negative 1 being greater than or equal to 0. This one does not work. I can try 1. So x equals 1. This gives me 2 times 1 minus 1 is greater than or equal to 0. So 2 times 1 is 2. Take away 1 is 1. 1 is bigger than 0, so this value works. I can also try x equals 1/2. I have 2 times 1/2. Take away 1 must be greater than or equal to 0. 2 times 1/2 is 1. Take away 1 is 0. So this one works. So this means that, again, x must be bigger than or equal to 1/2 in order for us to have a real number. So those are my restrictions. Solving this radical equation. Step 1 is to isolate the radical. So that means that I want to leave the square root of 2x minus 1, and I want to move this positive 5. So I'm going to subtract 5 from both sides, and I end up with the square root of 2x minus 1 equals 7. Once I've isolated the radical, I can square both sides of my equation. On the left-hand side, when I square the square root of 2x minus 1, I'm just left with 2x minus 1. On the right-hand side, 7 squared is 49. I now need to solve this equation for x. So add 1 to both sides. I have 2x equals 50. Divide both sides by 2. And my solution is that x equals 25. Whenever we're working with radical equations, we must verify the solution because sometimes things go wrong in this step where we're squaring, and some of our roots will become extraneous. Extraneous means that they're not acceptable. They don't make a true equation. So I want to verify my solution. To verify, I want to substitute in x equals 25 into my original equation. So my original equation is 5 plus the square root of 2 times x. X is now 25. Take away 1, that's all under my root sign, has to equal 12. So 5 plus the square root of 2 times 25 is 50. Take away 1 needs to be 12. So 5 plus the square root of 49 equals 12. This becomes 5 plus 7 equals 12, which it does. Therefore, my solution is verified. We can express solutions as a solution set and show that the acceptable answer is 25. What are the restrictions on n if the equation is n minus 5 minus n equals negative 7? Solve the equation. So restrictions first. Restrictions means that 5 take away n has to be greater than or equal to 0. Well, if I substitute in 5 into this equation, I get 0. What if I substitute in a number larger than 5? So if I try n equals 6, I end up with 5, take away 6 being greater than or equal to 0. That one doesn't work. So I know then that n must be less than or equal to 5. These are my restrictions. Solving the equation. I have n minus the square root of 5 minus n equals negative 7. Step 1 is still the same. I want to get my radical by itself. So I have n on the front. I need to subtract n from both sides. And I have negative root 5 minus n equals negative 7 minus n. I can get rid of the negative out front by dividing both sides by negative 1. Leaves me the square root of 5 minus n equals positive 7 plus n. The next step is to square both sides. On the left, I end up with 5 take away n. On the right, I have 7 plus n all squared. This is the same thing as having 7 plus n times 7 plus n. To solve for n, I need to distribute on the right. So I have 5 take away n equals, we're going to distribute. 7 times 7 is 49. 7 times n is 7n. So that was this step. Now I'm doing here, 7 times n is plus 7n, and n times n is plus n squared. Gathering like terms, I have 5 take away n equals 49 plus 14n plus n squared. The next step is that I want to be able to solve this equation, and so I want to be able to make it equal to 0. So I'm going to subtract 5 from both sides, and I'm going to add n. On the left, we're left with 0. On the right, 49. Take away 5 is 44. 14n plus n is 15n plus n squared. In order to solve this equation, it's now a quadratic equation, and previously we learned to solve it by factoring. So I can factor this into 2 factors, and I can factor it with the box method or trial and error, and I end up with 2 factors of 11 plus n and 4 plus n. I need to make each of those factors equal to 0. So 11 plus n is the same thing as n plus 11. Can be equal to 0, or n plus 4 can be equal to 0. Subtracting 11 from both sides gives me n equals negative 11. And on the right, n equals negative 4. Remember that we need to now verify those roots. So to verify, we are going to substitute back into the original equation. So let's start by verifying that x. n is equal to negative 11. To do that, I'm going to substitute back into my original equation, which was n minus the square root of 5 minus n equals negative 7. So negative 11 minus the square root of 5 minus negative 11 equals negative 7. Negative 11 minus the square root of 5 minus negative 11 is 16, has to equal negative 7. I end up with negative 11 minus 4 equals negative 7, which it does not. Therefore, n being equal to negative 11 is called an extraneous root. And we'll disregard it in our solution set. We now need to verify our other value, or our other solution, of n equals negative 4. We end up with negative 4 minus the square root of 5 minus negative 4 equals negative 7. Negative 4 minus the square root of 9 has to equal negative 7. Negative 4, take away the square root of 9 is 3, equals negative 7. This one verifies, and so our solution set is n equals negative 4.